Hello everyone, welcome to the class. In this tutorial, I am going to discuss Entity Relationship Diagram or ERD for the subject Software Engineering. This ERD diagram tutorial will cover their uses, history, symbols, notations and how to draw them. Also, we will see the benefits of ERD diagram. Now, the first question is, what is an ERD diagram? An entity relationship diagram or diagram or ERD is a visual representation of different entities within a system and how they relate to each other. For example, the elements writer, novel, and a consumer may be described using ERD diagram like the following way in this figure. Okay, so here it is the ER diagram with the basic objects. They are also known as ERDs or ER model. Here you can see the writer who creates the novels, okay, then the consumer and the buyers. And what are these rectangles and other figures? We'll cover all these things later in this tutorial. Now this tutorial will cover, as I said, history of ER diagram uses, ER diagram symbols and notations, ER diagram, how to draw ER diagrams, ER diagram templates and benefits of ER diagram. Now if we talk about the history of ER diagram, we can see that although data modeling has become a necessity around 1970s, there was no standard way to model databases or business processes. Although many solutions were proposed and discussed, none were widely adopted. Peter Change is credited with introducing the widely adopted ER model in his paper, The Entity Relationship Model Toward a Unified View of Data. The focus was on entities and relationships, and he introduced a diagramming representation for database design as well. His model was inspired by the data structure diagrams introduced by Charles Bateman. One of the early forms of ER diagrams, Bateman diagrams, are named after him. Now, what are the uses of ER diagrams? ER models in database design. What are the if we say regarding the uses of ER diagram or where they are used, we will see that although they can be used to model almost any system, they are primarily used in the following areas like ER model in database design. They are widely used to design relational databases. The entities in the ER schema becomes tables, attributes and converted the database schema. Since they can be used to visualize database tables and their relationships, it's commonly used for database troubleshooting as well. Now, ER diagrams in software engineering. Entity relationship diagrams are used in software engineering during the planning stages of the software project. They help to identify different system elements and their relationships with each other. It is often used as the basis for data flow diagrams or DFDs as they are commonly known. For example, inventory software used in a retail shop will have a database that monitors elements such as purchases, item type, item source and item price. Rendering this information through an ER diagram would be something like this figure. In this diagram, the information inside the oval shapes are attributes of a particular entity. Entities are shown by these rectangles. Now, if we look at the ER diagram symbols and notations, we can see this the rectangle represents the entity, then this oval represents attribute, and this diamond represents the relationship. Okay, some other symbols are also used in this ERD. Those are weak entity, multi-valued attribute, and weak relationships. There are three basic elements actually in this ER diagram. They are entity, attribute, and relationships. And as I said, there are more elements which are based on the main elements. They are weak entity, multi-valued attributes, and derived attribute. Weak relationship and recursive relationship. Now, cardinality or ordinality are two other notations used in ER diagrams to further define relationships. Now, if we talk about the entity, which is the first one, or the first word of entity relationship diagram, we see that an entity can be a person, place, event, or object that is relevant to a given system. For example, a school system may include students, teachers, major courses, subjects, fees, and other items. Entities are represented in ER diagrams by a rectangle and named using singular nouns. Then there is weak entity. A weak entity is an entity that depends on the existence of another entity. So this is very important, that weak entity depends on the existence of another entity. In more practical terms, it can be defined as an entity that cannot be identified by its own attributes. It uses a foreign key combined with its attributed to form the primary key. And as we know, the primary key is the unique key for a database. Next, an entity like order item is a good example for this. The order item will be meaningless without an order, so it depends on the existence of the order, like here. Now, if we talk about the attribute, an attribute is a property, trait, or characteristics of an entity, relationship, or another attribute. For example, the attribute inventory item item name is an attribute of the entity inventory item. An entity can have as many attributes as necessary. Meanwhile, attributes can also have their own specific attributes. For example, the attribute customer address can have the attributes number, street, city, and state. These are called composite attributes. Note that some top-level ER diagrams do not show attributes for the sake of simplicity. In those that do, however, attributes are represented by oval shapes. Here you can see the oval shapes. Right? Now, next one is the multi-valued attribute. If an attribute can have more than one value, it is called a multi-valued attribute. It is important to note that this is different from an attribute having its own attributes. For example, a teacher entity can have multiple subject values. So, this subject is the multi-valued attribute. Next one is derived attribute. An attribute based on another attribute. that is derived attribute. This is found rarely in ER diagrams. For example, for a circle, the area can be derived from the radius, like here. Okay. Next one, recursive relationship. If the let's talk about the relationship first, then we'll go for the recursive relationship. A relationship describes how entities interact. For example, the entity carpenter may be related to the entity table by the relationship builds or makes. Relationships are represented by diamond shapes and are labeled using verbs. Next one is the recursive relation. Recursive relationship. If the same entity participates more than once in a relationship, it is known as recursive relationship. In this example, an employee can be a supervisor and be supervised. So there is a recursive relationship. Now, if we talk about the entity set and keys, key is an attribute or collection of attributes that uniquely identifies an entity among entity set. For example, the roll number of a student makes him or her identifiable among students. Then we will get super key, a set of attributes, one or more, that collectively identifies an entity in an entity set. Then we will get the candidate key. A minimal super key is called a candidate key. An entity set may have more than one candidate key. And finally, we'll get the primary key. A primary key is one of the candidate keys chosen by the database designer to uniquely identify the entity set. Next, we have the cardinality or ordinality. These two further defines relationships between entities by placing the relationship in the context of numbers. In an email system, for example, one account can have multiple contacts. The relationships in this case follows a one-to-many model. There are a number of notations used to present cardinality in ER diagram. Chain, UML, crows, foot, Bachman are some of the popular notations. The following example uses UML to show cardinality. This one, that email account is one and it can have the multiple contacts. So this one email account can have multiple contacts, that is 0 to n. Okay, has is the relationship and there are two entities, email and contact. So it is one to many relationship. Now, if we get the cardinality, it is shown that one-to-one relationship. Okay, after that, one to many. When more than one instances of entity is associated with the relationship, it is marked as 1:n. The following image reflects that only one instance of entity on the left and more than one instance of an entity on the right can be associated with the relationship. It depicts one-to-many relationships. Just you can see that at the left it is 1 and at the right it is n. Then many-to-one, when more than one instance of entity is associated with the relationship, it is marked as n:1. The following image reflects that more than one instance of an entity on the left and only one instance of an entity on the right can be associated with the relationship. It depicts many-to-one relationship. Then many-to-many, as you can see from these previous figures, many-to-many will be n:n, like this figure. And if we talk about the participation constant, total participation and partial participations are there. Now, if we talk about the total participation, each entity is involved in the relationship. Total participation is represented by double lines like this: total participation at the left side, and partial participation. Not all entities are involved in the relationship. Partial participation is represented by a single line like the right hand side here. Now again, if we come back to our slides, we'll get how to draw ER diagrams, and this is very, very important. Now these points will show how to draw or how to create ER diagram. Now first of all, identify all the entities in the system. An entity should appear only once in a particular diagram. Create rectangles for all entities and name them properly. Then identify relationship between entities. Connect them using a line and add a diamond in the middle describing the relationship. Add attributes. Number 3, add attributes for the entities. So first identify all entities, then mark them and represent them with a rectangle, then identify relationships between the entities and represent them with the diamond, and finally add the attributes for the entities. Give meaningful attribute names so that they can be understood easily. Sounds simple, right? In a complex system, it can be a nightmare to identify relationships. This is something you will perfect only with practice. Now, what are the ER diagram best practices? Provide a precise and appropriate name for each entity, attribute, and relationship in the diagram. Terms that are simple and familiar always beats vague, technical sounding words. In naming entities, remember to use singular nouns. However, adjectives may be used to distinguish entities belonging to the same class. It is part-time employee and full-time employee, for example. Meanwhile, attribute names must be meaningful, unique, system independent, and easily understandable. Then number 2, remove vague, redundant, or unnecessary relationships between entities. Number 3, never connect a relationship to another relationship. Number 4, make effective use of colors. You can use colors to classify similar entities or to highlight key areas in your diagrams. Now, if we talk about the ER diagram templates, you can see this is a ER diagram template which shows the entities, the relationships, and the attributes. Here it is a representation of examination system where the exam attendees sit for the exam, right? And where the exam record will be shown in the record card. Okay. Now, if we see the exam attendees, their entities, there are examinee's name, student number, phone number, and email. So these are the attributes for the entity of exam attendees, right? And what is the relationship between the exam attendees and exam? Obviously, exam attendees will sit for the exam, and here the exam attendees will sit here for the exam, and sit is the relationship, okay, between these two entities. Now, in exam there are two entities, exam number and subject. So what is the subject you want to sit for, that will be shown by this subject attribute. Okay, next one, exam and exam card, that is record card. So both of them has a relationship with record. Okay, so exam record will be shown through the exam record card, and the attributes for the record cards are record number, subject, name, and then score. Okay, so by this way we can draw an ERD. Okay, it's a very simple example. Now if we look regarding more complex ERD, that is shown here, it is an ER diagram for hospital management system, a simple ER diagram. Okay, see, entities are patient, medicine, treatment, patient here, medicine, treatment, rooms, nurse. Nurse is the weak entity, also the treatment is also a weak entity, right? So doctor, receptionist, permanent, this record, employee, all these are entities, this trainee. Okay, and these diamond shapes are the relations. Okay. So if we look at the patient here, the patient will have the attributes like patient ID, name, then sex, address, pedals. Okay, means here also two sub attributes, they are date admitted and date discharged. Then and multivalued attribute is also there, that is the contact number, because a patient can have more than one contact number, right? Now then rooms are also there. Here rooms are the hospital rooms types, room ID, period. Okay, for staying at the room, all these will be the attribute for the room. Okay, now here assigned, patient will be assigned in a room. So assigned is the relationship between the patient and the rooms. Again, there is doctor is an entity, and doctor is a trainee, or doctor can be visiting, or the doctor can be permanent, right? So what is the relation between this patient and doctor? Doctor attends the patient, right? And also here, as you can see, there are more relationships between the patient and the medicine. Okay, then just a minute. Yeah, patient and the medicine, then the treatment, rooms, nurse, employee. So doctor, here you can see the doctor is a employee, also nurse is a employee of the hospital. Okay, again in a hospital there is another entity, that is a receptionist who maintains the record. Whose record? What record? The appointment, patient ID, okay, the description, the record number. Okay, so these are the attributes. Again, the receptionist is also a employee. So doctor is a employee, receptionist is also an employee, nurse is also an employee of the hospital. Now if you, so employee will be the another entity, and this entity will have multiple attributes like EID, that is employee ID, salary, employee address, sex, NID, E-name, that is employee name, history, and there is a contact number. And as contact number, an employee can have multiple contact numbers, so double overlay is there, and it is also called multivalued attribute. Okay, so as a whole you can see this is the this is an example of hospital management system. This is an example of ERD of hospital management system. Okay, right? Now if we talk about the benefits of ER diagram constitute a very useful framework for creating and manipulating databases. First, ER diagrams are easy to understand and do not require a person to undergo extensive training to be able to work with it efficiently and accurately. This means that designers can use ER diagrams to easily communicate with developers, customers, and end users, regardless of their IT proficiency. Second, ER diagrams are readily uh, translatable into relational tables, which can be used to quickly build databases. In addition, ER diagrams can directly be used by database developers as the blueprint for implementing data in specific software applications. Sorry. Lastly, ER diagrams may be applied uh, in other contexts, such as describing the different relationships and operations within an organization. So I have tried to cover all you need to know about the ER diagrams basics. If you think I have missed some part, make sure to mention that in the comment section. It is a good place to ask question too. If a question is asked frequently, I can add this to frequently asked question section. Okay, so I hope you have understood this topic. Thank you for watching.